In this lesson, we're going to be factoring out a greatest common factor. So a problem's going to ask, factor out the GCF, and here's what it may look like. So the greatest common factor is we're looking for what is the biggest value or variable that we can take out of both pieces. So for this particular problem, our greatest common factor between these two, they don't share a variable that matches, but they do have a factor of 2 that we can divide out of each piece. So the greatest common factor is 2. So factoring is basically undoing distribution. So if distribution is multiplication, then factoring is going to be division. So we are going to factor out a 2 from each of these pieces, which basically means we're going to divide by 2, divide by 2. So that'll leave us with a 2x plus 3y. And now there's nothing else that they have in common. They don't have a number that we can factor out anymore. They don't have a variable we can factor out anymore. And 2 was what we can take out of each piece. So that is as far as we can go as far as factoring by greatest common factor. All right, let's look at another one. If you have 6x squared plus 3x, what do they have in common? Well, they both share a number that potentially we can divide by the same value. They both share a factor of 3. So the greatest common factor would be a 3. And letter-wise, variable-wise, we're talking about that they both share an x. So we can at least take one x away from each of them. So our greatest common factor is going to be 3x. So we'll factor out a 3x. If we divide this by 3x, 6 divided by the 3 gets us a 2. And if we have x squared, we're factoring out an x, we really just lose an x. So you have 1x left over. And then plus 3x divided by 3x is 1. And people will miss that piece thinking that it cancels completely, but if you distribute this back in, you should get your original. So 3x times 2x gets you 6x squared, and 3x times 1 is what you get you with 3x. If that piece is gone, then you won't get your 3x anymore. So when you divide out the exact same piece that you have, you'll always have at least a 1. All right, so that one is done. All right, so let's say you have a 15t to the 6th plus 25t to the 4th minus 20t squared. What do they all have in common? Well, they share a common factor of 5. So they're all going to be divisible by 5, and they all have at least a t squared on them. So we can divide every single piece by a t squared, 5t squared. All right, so 15t to the 6th divided by 5t squared, dividing it out, is going to get us a 3t to the 4th. We had 6 t's, we're taking out 2 of them. It's going to leave us with 4. And then plus 5t to the 2nd. We had 25 divided by 5. T to the 4th, we're taking 2 of the t's away from it. Leaves us with a t squared minus 4. Because 20 divided by 5 is 4. Keep the sign. And we had 2 t's, we're taking out 2 t's. So there's no more t's left on that. And that's it. Now this, in the future, may be factorable further. But we're not worried about it quite yet. We're just talking about greatest common factor. So let's do a 4th. If you have a negative 3m to the 4th n to the 5th, minus 13m to the 3rd n to the 6th plus 26m squared n to the 7th. All right, a little bit more complicated. So between all the numbers, they all are divisible by 13. Now that first term, we're going to have to try and keep a habit of making it positive. So if you do have a negative in the front here, it's going to be in your best interest to factor out a negative with it to make the first term positive. N's. We have an n to the 4th, n to the 3rd, n to the 2nd. They all have at least n to the 2nd, or m to the 2nd. So they all have at least an m to the 2nd. N to the 5th, n to the 6th, n to the 7th. They all have at least 5 n's here. So n to the 5th. That is our greatest common factor. So we'll take the negative 13m squared n to the 5th out. And we're dividing a 13 by a 13. Negative divided by a negative is going to cancel it, make it a positive. So that's actually just going to become a 1. And if we have variables, we won't need to write the 1. And we will. So we have m to the 4th, we're losing 2. So that leaves us with m squared. We had 5 n's, but we're taking out 5 n's. So that's it. Becomes a positive m to the 2nd. So we go to the next term. We're dividing this piece away, so that again is going to become a positive 1. And if we don't have any variables, we'll put it actually a plus 1 here. But we are taking 2 m's out, so that'll leave us with an m. We had 6 n's, we're taking out 5. That'll leave us with an n. And then we go to the last term. 26 divided by the negative 13 will be a negative 2. And we had m squared, we're taking out m squared, so all the m's go away. N to the 5th, or n to the 7th, we're taking out n to the 5th. That leaves us with n squared left over. And that is that piece, factored as far as it can, as far as greatest common factor. Again, there's maybe potential that this could factor further, but that's for another time. All right, last one. 5 times x minus 1 minus 2x times x minus 1. Now this one's a little tricky. So what do these two pieces have in common? Well, this is one term, this is another term. Addition and subtraction kind of separate that. So these two pieces actually have an x minus 1 in common. So back here, if you have an x or a number or something in common, this is what you factor out. So we're going to factor out x minus 1 because our greatest common factor actually is x minus 1. So that's the piece we're going to factor out. Now we're going to multiply it by something else, so I'm going to leave it in its parentheses. So this is what we're factoring away from both of them. Essentially they go away just like here. When you factor out a 3x, the 3x is being removed from each of the pieces. So the x minus 1 is being removed from each of the pieces. So you're left with, if this goes away once you factor it, you're left with 5 on this term and a minus 2x on this term because you factored out and condensed it into an x minus 1. And that's it. All right, that was factoring out greatest common factor.